Today we are going to discuss about one of the things that students are getting confused of pretty easily: intermolecular forces versus intramolecular forces. At some point in chemistry, when you are learning about chemical bonds and forces, you may have felt some confusion about it. So today we are going to clear all the confusions and make it all easy. And of course, when we are done with all our examples and lectures, you're going to have a proper note. So let's start with intramolecular forces. First of all, let's talk about the word intramolecular. Okay, so intramolecular. What does intramolecular mean? So intramolecular basically have two parts. First of all is intra, then is molecular. Let's take it as intra means inside. So intra means inside, and molecular, inside a single molecule. We can put it like this: intramolecular means inside a single molecule. So we can say that something is happening inside a single molecule. What is happening? We're looking for force. Okay, so we are talking about the forces inside a single molecule. We are not talking about multiple molecules. Remember, that's the trick here. That's the trick to remember it and understand it pretty easily. First of all, inside a single molecule. That is intramolecular. Remember again, intra means inside and molecule is obviously a single molecule. Okay, so intramolecular means inside a single molecule. Now let's talk about three different compounds and see how we can actually relate to intramolecular forces. First of all, let's talk about sodium chloride. So we know that inside sodium chloride we have sodium plus cations and chlorine minus anions. These cations and anions are attracted to each other by electrostatic forces, right? Just write that as a force. We have a force there. That force is holding these two together, okay? And that is why they are forming the sodium chloride. Okay, now let's talk about another one. Let's talk about HCl. So we have hydrogen and chlorine. We know that this is a covalent compound. So we have shared pairs of electrons. So we basically have shared pairs of electrons, and these shared pairs of electrons are attracted to the nuclei. Which are the nuclei? The nuclei are chlorine and hydrogen, right? By strong electrostatic forces. Then again, we have a force here. They're holding the shared pairs of electrons and the nuclei together. Okay. Now let's move on to another example. A metal. It's a magnesium. We know that inside a metal we're going to have delocalized electrons, right? So delocalized electrons. These delocalized electrons again are attracted to the positive magnesium 2+ nuclei, right? Again, the delocalized electrons are attracted to a positive nuclei with another force. And all these three forces are electrostatic forces, right? Because positive something is attracting another negative something. Now, these forces exist inside the molecule. You can see here, inside sodium chloride, we have the forces inside the molecule, inside a single sodium chloride molecule, inside a single hydrochloric acid molecule, and inside a magnesium molecule, okay? So the forces that are holding the atoms, ions, or whatever together inside a single molecule and forming the compound, they are the intramolecular forces. And intramolecular forces are basically of three types. First of all, you can actually relate to this one, sodium chloride. So we have ionic bonds, and then we have covalent bond, and lastly we have the metallic bond. Okay, that's it. Just let's do a recap. First of all, intramolecular means inside a single molecule, and in a ionic compound we have ionic bonds where the positive cations and negative anions are attracted to each other by electrostatic forces inside sodium chloride. Again, inside hydrochloric acid, which is a covalent compound, so we have covalent bonds. Shared pairs of electrons are attracted to the nuclei inside HCl. Again, inside magnesium we have delocalized electrons attracted to the magnesium 2+ cations by again electrostatic force, which is in a metallic bond, which is a metallic compound, and we have metallic bonds. So all these three bonds are made by the forces, and these forces are actually making these compounds. So these are called intramolecular forces. Now let's look at the points we can draw from intramolecular forces. Now again, let's focus on the word intermolecular. What does intermolecular means? Inter, we have two words again, inter and molecular. First of all, think about international flights. International flights, what does it mean? It means that the flight between different nations, right? Separate nations. That's the same thing here. Intermolecular, that means the forces, if we talk about intermolecular forces between separate molecules. Remember the first one, the intramolecular. Here we had one single molecule, the forces inside one single molecule. Now, intermolecular means between separate molecules, not a single molecule, between separate molecules. That means if we talk about, let's say, the force between, you have a beaker of water, let's say H2O, one H2O is bonded to another H2O. There are some force, not bonded, we can talk about this, you can just say that it's forces. There's a force between this H2 and that H2. That H2 is also has a force with another H2. Not inside, whatever is happening inside, we're not talking about it. We're talking about the relation between this molecule to that molecule, that molecule to that molecule. The forces between separate molecules, we call them the intermolecular forces. Now, there are three main types of intermolecular forces. First of all is the London dispersion force. London dispersion force. Okay. This happens due to the movement of the electrons. When one side has more electrons, the other side becomes positive and negative. We will discuss everything about London dispersion force in our next video, so stay tuned. Now, the second one is permanent dipole forces. Dipole force. Okay, this is the second one. When one of the atom is very electronegative compared to the other one, then this forces actually happen there. For example, let's say you have H2O, again H2O, oxygen is very electronegative compared to hydrogen, then we will have permanent dipole forces in there. We will also discuss about this thing later. Number 3, we have the king of intramolecular forces, which is hydrogen bonding. Now, when hydrogen is bonded to 3 special atoms like oxygen, fluorine, and nitrogen, then we have a hydrogen bonding in there. You have noticed that I have used H2O for example for all these 3 forces, because these 3 forces exist in all in H2O. All these 3 forces exist in H2O. So we'll discuss about each of the forces in different videos, not here because they need a broader explanation. Okay, just for now, you know that intermolecular forces is between separate molecules, and we have 3 main kinds of intermolecular forces. First of all is London dispersion force, second is permanent dipole force, and the third one is the hydrogen bonding. So that's it. Now let's look at the notes we can write from intermolecular forces. Now that we are done with explanation and notes, now let's look at the differences. One last recap. First of all, the location. Intramolecular forces again inside a single molecule, and intramolecular forces is between separate molecules. Then comes strength. Intramolecular forces are very strong. Intermolecular forces are relatively weak. They are very weak basically. And then we have types. So we have 3 types of intermolecular forces, which are covalent, ionic, and metallic. And intermolecular forces, we have London forces, permanent dipole forces, and hydrogen bonding. And again, the features, what these forces are controlling. Intramolecular forces control the chemical properties, just like sodium chloride. If you break these forces, their chemical properties is gone, right? Sodium chloride is not a salt anymore if sodium and chlorine are not bonded together, right? So the intramolecular forces control the chemical properties of the compound and of the molecule. Okay, and intermolecular forces basically control the physical properties like the boiling point, the melting point, the viscosity. These physical properties are controlled by intermolecular forces. Depending on intermolecular forces, some gases, some liquids may have higher boiling point, some liquids may have lower boiling point, this kind of things. We will obviously discuss about it later. Stay tuned for the next video. London forces are coming. Now the last one, the features. How much energy you need to break them? Intramolecular forces are very strong. Obviously, you need extremely high energy to break these forces. And for intermolecular forces, as they are weak forces, you need low energy to break them. So that is it for intra versus intramolecular forces. I guess you are very clear now. If you have any question, you can just ask me in the comment box. See you in my next video. Stay tuned. Do not miss that London forces video. Bye bye.